More on regression, one predictor, MATH5130, Doug Darbro. This should be a brief video if I can keep from going down too many rabbit holes. First thing I want to tell you about are influential points, so I want this to be on your radar. An influential point is just a point or points that strongly affect the characteristics of the graph of a regression line, namely affect the slope and the intercept. So if we look at the graph on the left, clearly we have a linear pattern, positive slope, so we have a positive relationship, and a linear relationship. However, if we add 1 point, let's say we have a 73,50, which is right here where I'm circling, it really dramatically changes the line, changes the intercept, it changes the slope dramatically. And so we would need to have on our radar that this point is an influential point and decide whether or not we're going to retain it in the model. Residual. All right, let's pump the brakes. Super, super important concept. Residuals play a very important role in model diagnostics and testing assumptions. So what are residuals? They are the observed y minus the predicted y. Again, observed y minus predicted y. So the observed y is the y that we get from our data set. The predicted y is the y that we would get if we put that x value in our model and predicted the y. So the difference between what we observe and what our model predicts is called a residual. The positive residual tells us that the observed y is greater than the predicted y. That should make sense. The only way we can take a number and subtract another number and get a positive number is if this one's bigger. A negative residual tells us the observed y is less than the predicted y. The only way I can go this number minus that number and get a negative number, 2 minus 5 is -3. The 5 is bigger than the 2, so the predicted value is greater than, or the observed is less than the predicted. Residual 0, you don't see these often, but if you do, then it says that the observed y is the same as the predicted y. Very rare to see that. So I think this will make a little bit more sense if we dive into an example. So let's circle back to this white blood count, red blood count, and we've created our model. So let's calculate the residual for a couple of cases. So case number 1, right here, this person has a white blood count of 8.7. They have a red blood count of 4.8. So my observed y is the y I get in my data set, 4.8. The predicted y is taking our model and inserting that case's x value in the model and predicting the y. Okay? So the difference is right here, the observed 4.8 comes from the data, minus the predicted comes from the model, so -0.269. Now, case number 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. This is number 9 down here. White blood count 10.9, red blood count 6.34. What's the observed red blood count? 6.34, it's in our data set. What's the predicted? Well, let's put the x value, the white blood count, in our model, and we get 5.986. So the residual is the observed minus the predicted. It's 3.54. So we have a positive residual because the observed is greater than the predicted. We have a negative residual in case 1 because the observed is less than the predicted. Now residuals are super, super easy to calculate with technology. StatCrunch does it easily. R does it easily. If I create my model, all I have to do is just go type RESID, whatever I named my model, and it spits them out. So you can see that the residual for the first case is -2.69, the same thing that we got. And you can see that the 10th, it's off a little bit because I've crunched it down to where it fit the screen better. But first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, right here would be the 9th. Residual 3.54, just as we calculated. Residual plots, something we'll use to test assumptions. Residual plot is just where we plot the residuals over the x value. And what we look for in residual plots is no obvious pattern. Our residuals should be random and not have a pattern to them, and the residual plot should not become wider or thinner when moving from the left to the right. I think this will be better in pictures. So notice over here, no patterns really. The residuals are kind of just all kind of, I always say kind of like a shotgun blast, just no discernible pattern. It tells us we probably got a good model. Notice how I have a pattern here. That tells me I have a horrible model. I should not be using this model to make predictions on y using the x values. I should not, this model is not good. And this one's the same way. Notice how when I move to left to right, there's little variation. But when I move to the right, I have this fanning out, as we call it. A lot of variation over here. This violates something what we call an equal variance assumption of the residuals. Variances aren't equal across the levels of x, so bad model. All right, gang, that's all I got. We're going to move into examples, develop simple linear regression using R and StatCrunch, and then start adding predictors, and then we move into what we call the multiple regression world, where we have multiple predictors. It's really cool stuff and extremely applicable to the nursing, occupational, and health sciences fields. All right,